Okay, I am on page 8 of the class packet, and this is the last review set. So again, I'm on page 8. So I have the review set posted into Classroom, the review set quiz. So you can either take it today after we do this together, or maybe you've already taken it. That's fine too. But I'm going to go through this with you real quick. So in this first one, the first 4 terms of an arithmetic sequence are given. Arithmetic means you're adding a number. In this case, we're adding 5 each time. And it says, what would be the 60th term? So we're having to solve, which means I need to use the explicit formula for arithmetic, which is a of 1 plus n minus 1 times d. So that's the formula I'm going to use to find the 60th term, which means everywhere I see an n, I'm going to put 60. A of 1 stands for the first number, which is 27. And then d is what we're adding by, which is 5. Then I would just put that straight in the Desmos, and you should get 322, which would be the 60th term of the sequence. And I'm just going to check myself real quick to make sure. Yep, 322. So that's the first one. The second one, create g of x in terms of f of x. So that means you're going to start off by writing f of x, which means you're going to start at the f of x graph, which is down here. And I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8 to get to g of x. So it would be plus 8. And that's all you do for number 2. Okay, for number 3, what is the range? Range are your y values. So that means you're going to just look at your y-axis. If I'm looking at just my y values, the graph starts at 4 on the y-axis and goes down. So all my values of y would be less than or equal to 4. That would be the range. So there is the review set. And again, either today or tomorrow, make sure you take the review set quiz, which is on Classroom. Okay, I'm going to move on to page 9. And what I suggest you doing in this review up here, the warm-up, you're answering all these questions based on the box and whisker plot. I would probably pause the video and try to go through this on your own first, and then come back and I'm going to go over the answers just to make sure you're on the right track. So, okay. So I'm going to assume that you paused it, and I'm going to go over the answers. So the median would be 62, because that's where the line is in my box. The lower quartile, quartile 1, would be 60. The upper quartile, or quartile 3, would be 64. The minimum is my whisker, that would be 58. The max is my other whisker, which would be 66. And then it says the above 5 values. So the median, Q1, Q3, mid, max, they call that the 5-number summary, meaning those are just the 5 numbers you need to calculate first before you can graph your box and whisker plot. Next it says, what is the range? So the range is going to be your max minus your min. So 66 minus 58, which would be 8. Next it says, what percentage of data is below the upper quartile? If you remember from yesterday, each section is broken up to 25%. So when it says what percent is below the third quartile, that would be 75. So it'd be 25, 25, and 25. Next, it says what percent is located between the lower quartile and the median. So if I look from Q1 to the median, that's just one section, so that would just be 25%. So that is just a little quick review of what we've done this far. Now we're going to go ahead and move through, and I'm going to do pages 9 and 10 with you. Page 9, 10, 11 maybe. We'll see how far we get. So what we're going to be doing today, so up to this point, we've looked at box and whisker plots for our data. Now we're going to look at scatter plots, and some of it's going to be review. For example, last year, I believe you would have to graph a scatter plot, which is just plotting your points. And you would have to draw what they call a line of best fit through them. A line of best fit is basically a line that you try to put in the middle of your points. Ideally, go through as many points as possible, which is not always realistic, but you hopefully have roughly the even amount of points on each side of your line. So I know you did that last year. With that being said, what we're going to do today is just describe the correlation between the two sets of data that we're comparing. And what I mean by that is, like this first one, for example, we would say this has a positive correlation because it's increasing. This we would have a negative correlation because it's decreasing. And this one we would say is no correlation because there is no trend. It's just kind of all over the place. So all of this, I believe you did last year. The new part is this correlation coefficient, which they use the letter R to represent this coefficient. And what this is, it's a number between -1 and 1, and it basically describes, someone's calling me on my classroom phone, so just give me a second. I'm sure it'll stop ringing eventually. Yay, it did. Okay, hopefully it wasn't an emergency. Okay, so it's a number between -1 and 1. This number describes basically how close your data is to making a perfect straight line. The closer it is to making a perfect straight line, the more of a strong relationship you have between your data. So it kind of gives you a breakdown right here. Whether you're doing a positive line or a negative line, the closer your number is to 1 or -1, the stronger you have a relationship. No correlation would be closer to 0. So for example, if I say the amount of groceries I buy is going to increase the amount of time I watch TV. So the amount of groceries I buy is going to increase the amount of TV I watch. That would have a no correlation, a correlation coefficient close to 0, because that doesn't really have a trend. But if I say the more groceries I buy tends to increase my grocery bill, that's going to have a number close to +1 or -1 if I'm given a negative situation, because that's going to be a very strong relationship there. So that's what I mean by strong or no correlation. Is it going to be something that has a really strong trend to it, makes a good straight line, or is it going to be something like this where it's just all over the place? So we're going to look specifically at these numbers. So in this first one, a study compared the number of years of an education a person received and that person's average yearly salary. It was determined that the relationship between these two quantities was linear and the correlation coefficient was 0.91. Which conclusion can be made based on this study? There was a weak relationship, a strong relationship, no relationship, or unpredictable relationship. Well, based on that number, 0.91, that is very close to +1. So that means there is a strong relationship between an education and that person's average yearly salary. The next one. What is the correlation coefficient of the linear fit of the data shown below to the nearest hundredth? So it gives us this option, and again, it's wanting us to find that letter R, that number that describes how close my data is to making a straight line. Well, first of all, my data is going down, so I can automatically delete 1 and 2. It's going to have to be a negative number. Now, I have -0.93 and I have -1. For it to be -1, that means it's making a perfect straight line. It's not, so that means it's going to be 3. It's close, there's a strong relationship, but it's not a perfect straight line. Okay, so I'm going to move on to page 10. Same thing. We're going to keep practicing with that correlation coefficient number. So what could be the appropriate, or what could be the approximate value of the correlation coefficient for the scatter plot? So it's increasing. So I'm going to cross out negative. So it's between 0.21 and 0.9. Well, it is pretty close to making a straight line, so that means there's a strong relationship, which means it's close to 1, so 0.9 would be the answer. Okay, the next one. Which value of R again is that correlation coefficient number, represents data with a strong negative correlation? So I'm going to cross out the positive answer. Strong negative means it has to be close to 1. So I can also cross out 3. It's between negative 1.07 and negative 0.89. Well, in this case, it's going to be negative 0.89. The reason for that is the correlation coefficient R is between negative 1 and 1. It doesn't go past negative 1. It doesn't go past 1. So negative 1.07 is above negative 1, so that can't work. So that is why it is 2. Okay. So this one, which graph represents data used in a linear regression, which is just a line of best fit, a scatter plot, that produces a correlation coefficient closest to negative 1? So I need a negative graph. So it's between, so I can cross out 2 and 3. It's between 1 and 4 because my data would have to be going down. And negative 1 means it's very close to making a straight line because that's, 1 and negative 1 means it's very close to making a straight line. So the answer would have to be 4. All right, this last one. The relationship of a woman's shoe size and length of a woman's foot in inches is given in the table. What would be the correlation coefficient to best represent this? So let's look at my x values. X's always go on top. My x's are going up by 1s, and my y values are going up by 0.25. Okay, so this means there is slope. It has a constant rate of change. Okay, it's going up, so I know it has to be positive, so I can delete 2. But since it does have a slope, it's going up by the same number every time in each row. That means we have a perfect straight line, so the answer would be 1. Okay, so again, the closer it is to a straight line, it's going to be close to 1 or negative 1. If it is a perfect straight line, then the answer is going to be 1 or negative 1, depending on if your data is going up or down. Okay. Over here, I think I'm going to stop there for today. I mean, this is review. It'll be more, but we'll review it tomorrow, so I don't want to make this video super long. So we're going to stop there. Make sure you do the questions in this video. Make sure you keep working on Delta Math, and let me know if you have any questions.